Hello everyone, welcome back. In today's exercise, we will model a complete mechanical part using several powerful CATIA tools. Let's get started.
I was dreaming in my sleep, now wide awake. With CATIA by my side, there's no mistake. Always had a wish to create and design. Now I'm building futures one line at a time. Could sketch a ship or design a plane. With CATIA, every dream I can sustain. Stay with me, I'll show you how it's done. Our journey to the stars has just begun. Dreams with CATIA come alive, stay tuned. In a world of possibilities, our talents bloomed. From the sketch pad to reality, watch us soar. With every click and curve, we crave for more. From the smallest bolt to towering steel, with CATIA, our thoughts become real. Together we'll create wonders to see. In this world of design, just you and me. Step aside now, let's make way. With CATIA, we'll change the day. Innovation's heartbeat, hear it beat. In the land of dreams, we find our seat.
Hello everyone. For today's exercise, I have chosen this shape. As you can see, it has a main body with a thickness of 3 mm. However, the horizontal tube has a thickness of 5 mm. I will use the solid combine tool to create the main body. After that, I will draw two vertical cylinders with a diameter of 28 mm and a height of 30 mm. In the third step, I will draw a horizontal cylinder with a diameter of 26 mm and a total length of 41 mm. After creating these features, I will use the shell tool to hollow the part with a thickness of 3 mm. Then I will create the holes in the vertical cylinders with a diameter of 22 mm. Now I will create the inner hole of the horizontal cylinder with a diameter of 16 mm. Here, because the body has a thickness of 3 mm, a step is created along the 16 mm hole. There is a suitable tool in the part design workbench to solve this problem. Finally, I will create all the fillets. Then I will compare the final model with the drawing. I will move one of the fillets. As you can see, not all dimensions are given in the drawing. I will use the DMU2D Viewer workbench for help. Since the measured dimensions are approximate, I will make corrections whenever necessary. First, I will define the origin point of the coordinate system. I will show this section to you with the mouse. Then I will define the coordinate axis. First, I want to draw this section. According to the 3D model, I will select the YZ plane in the drawing. Then I will enter the Sketcher workbench. If you look at the drawing, you will notice that the overall length, the height of the straight vertical section, and the radius of the outer edges are not given. I will obtain these dimensions using the DMU to the viewer workbench. The overall length of the part is approximately 99 mm. The height of the vertical section is approximately 8 mm. The radius of the outer edges is approximately 20.5 mm. According to the drawing, the radius of the upper arc is 70 mm. With this information, I will draw the first sketch. First, I will use the profile command to draw the straight lines. Then I will apply the dimensions and constraints. The bottom line is coincident with the horizontal axis. Next, I will draw a 3-point arc. Both ends of the arc are coincident with the ends of the vertical edges. The center of the arc is coincident with the vertical axis. I will set the arc radius to 70 mm. The sketch is now fully constrained and turns green. I will return to the part design workbench. I will select the XY plane and enter the sketcher workbench. Notice that the length of the first sketch is now aligned with the vertical axis. Therefore, I will draw the sketch so that its length is along the vertical axis. I will draw two circles with a radius of 20.5 mm. I will draw a center line from the center of the first circle to the center of the second circle. I will apply a vertical constraint to the center line. I will make this center line coincident with the vertical axis of the sketch. I will make each circle coincident with one edge of the first sketch. If you look at the shape, you will see that it has a curved profile in the middle section. I will measure this curve using the DMU2D viewer tool. Remember, this tool can also measure the radius of an arc. Keep in mind that measuring the arc here may result in a significant error. If your model looks very different from the drawing, adjust the dimension. I obtain an approximate radius of 43 mm. I will draw a circle with a radius of 43 mm. I will make the circle tangent to the two circles on one side. You can see that the center of the circle lies on the horizontal axis. Then I will draw another circle with a radius of 43 mm. I will make it tangent to the first two circles from the other side. Now I will trim the extra portions. I will measure the distance between the two arcs on the drawing. It is approximately 25 mm. Then I will measure the same distance on the sketch. It is approximately 27 mm. Therefore, I need to modify the two radii. I will change the radius from 43 mm to 37 mm. Then I will measure the distance between the two arcs again. Now it is approximately 25 mm. I will use the sketch analysis tool to make sure no unwanted geometry remains. I will return to the part design workbench. I will make sure that none of the sketches are selected. I will activate the Solid Combine tool. Then I will select the two sketches. I will click OK. The shape is created. I will rotate the view and look at the model from the side and the top. I will compare the generated solid with the drawing. Now I will draw the two vertical cylinders with a diameter of 28 mm. I will enter the sketcher workbench on the XY plane. I draw two circles with a diameter of 28 mm and position them. I will return to the part design workbench. I will use the path tool to extrude them to a height of 30 millimeters. Now it is time to create the horizontal cylinder. I will enter the Sketcher workbench on the YZ plane. I will draw a circle with a diameter of 26 millimeters. Then I will position it. I will return to the Part Design workbench. I will use the Path tool in both directions and extend it by 20.5 millimeters. Now look at the model. You can see that the top surface of the horizontal cylinder is higher than the 70 millimeters arc surface. However, it is not shown in the drawing. I cannot change the 13 mm dimension because this dimension is specified in the drawing. But I can change the height of the vertical line in the first sketch from 8 mm to 9 mm. I will do that. It looks better, but it is still not enough. I will increase the height of the line by another 1 mm. Now I can see that the top surface of the horizontal cylinder is slightly lower. I will measure the difference. It is approximately 0.5 mm. I will correct the dimension in the first sketch once again. The model is now complete. I will activate the shell command. I will set the thickness to 3 mm and select the bottom face of the part as the face to remove. I will click OK. The solid is now hollow. Now I will create the holes in the vertical cylinders with a diameter of 22 mm. I will use the hole tool. Then I will use the symmetry tool to create the second hole on the other cylinder. Now it is time to create the hole in the horizontal cylinder. I will enter the Sketcher workbench on its face. I will draw a circle with a diameter of 16 mm and position it. I will return to the part design workbench. I will create the hole using the pocket command. Now the problem appears. One section of the hole is larger than the rest. This step is 2 mm on each side. There is a tool in the part design workbench called thickness. It is a very useful and powerful tool. I activate this tool. I will enter 2 mm in the thickness field. Then I will click the face field to activate it. Now I will select the step face. This face turns brown. I will click OK. As you can see, the step has been filled. Now both surfaces are flush. I will do the same for the other side. I will use the dynamic sectioning tool to create a section view and inspect the model. Now I will create the fillets. First I will apply a 3 mm fillet around the cylinders. Then I will apply a 7 mm fillet around the outer shape. I inspect the part from the side and the top. From the top view, it seems that our model is different from the drawing. I will move the last fillet to the position of the first fillet. I will click the fillet with the mouse and drag it upward. I have placed the selected fillet as the first fillet in the specification tree. Now compare the generated model with the drawing again. You can see that the problem has been solved. As you have seen, it is possible to reorder features in the specification tree. However, this is not always possible. That is all for today's exercise. I hope you find it useful. See you in the next exercise. Goodbye.
Let's build the future. Come with me.